Good morning, Year 10s. Good to see you all. How's it all going? Did everybody have a nice long weekend? I hope you all did. Say hi on the chat, guys, so that I can do the register. Have a nice long. There we go. We've got, today is the last lesson before your test. Your test is on Thursday. I'm going to review the homework that you guys had on percentage yield. And then we're going to do just a quick kind of review of all the calculation types. We can go back to the original lesson. The very first one where we can look at them. Ah, there you guys are. I'll quickly do the register. Hey Boyang, hey Adri, hey Oleg, hey Ethan, hey Fatima, hey Natanya, hey Amber. Fatima's here. Chimon's not here. Kate isn't here yet. Amber is. No Z yet. Oh, there's Mary. Nice to see you, Mary. No Z yet. Got Natanya. Got Adri. Got Ethan. Got Boyang. Haven't got Ryan yet. Got Oleg. Got Mary. Look at that. Amazing. So only 4 people missing now. Just missing Zihan. Oh no. Yeah, missing 4. Chimon, Kate, Zihan, and Ryan. Let's see how long it takes them guys to show up. In the meantime, there's Chimon and Z. Amazing. Just Kate and Ryan now to go. I'll mark them as missing and we'll get going. I'll mark them as missing. And then we can just crack on with our lesson. Okay. Go back to the chat over here. There we go. Right. Okay, folks. Just gonna share my screen with you guys. And go with that one. Cool. Hide. Fab. Okay, guys, let's just quickly have a look at your homework. Let's go through your homework tasks. And you guys were doing percentage yield, which is there. Hey, Ryan, good to see you. I'll mark you as in on the register. Good to see you, dude. So this was your homework on percentage yield. So I'm kind of hoping that you guys realized that essentially it was actually 2 questions rolled into one. It's a reacting mass question, which is the level 8-9, which is where you guys want to be aiming for, followed by the percentage yield afterwards. So if you got stuck, don't worry about it. Make the corrections. If you need another worksheet, I can set you one. Yeah, that's not a problem at all. Okay, can I just quickly confirm on the chat, please, that this is the correct homework? I seem to have accumulated so many homework sheets and I haven't really labeled them hugely well. So if I can just have a quick shout out on the classroom, please, just to let me know whether or not this is the correct one. I would very much appreciate it, very much. Let's see how long it takes for someone to notify me. Hi, sorry, the video wasn't showing up for some reason. Hey, Kate, good to see you. Don't worry about it, it's absolutely fine. You're glad you're here now. I'll mark you as in on the register. Yes, that's the worksheet. Fab. Kate's just arrived and she was the one that responded to me. Come on, guys. Everyone else is here waiting and watching. They should have commented, guys, you've gone quiet. I don't like it. Come on. Okay, thanks, Kate, for that. You're a star. Right, calculate the mass of iron. Okay, so first thing, calculate the mass of iron. So this is what we're calculating. I'm going to do this in red. I always think it's worthwhile me doing this in red. It's by far the best choice. Calculate the mass of iron. Oh, I'm going to shrink that, actually, and make that thinner. Yeah, I'll do that one. The mass of iron from 126 grams of iron oxide. Okay, so I'm going to do the odd thing here, and I'm going to rewrite the equation because I just like it to be nice and easy for me to see what's going on and follow my steps. Yeah, it's me kind of having this routine that I quite like to have. So step number 1, get to moles. Step 1, moles. So we have 126 grams of iron oxide. How much does iron oxide weigh? Right, I'm going to do this bit over here. So iron is 56, and there's 2 of them. I'm going to add that to oxygen, which is 16 times 3. Yeah, total number, got my calculator on hand. 56 times 2, might help if I turn my calculator on, plus 16 times 3 gives me 160. Right, so 126 divided by 160 gets me 0.788 moles. So that's 3 sig fig, but I've kept the number on my calculator. What's now step number 2? I'm going to switch to red again. Step 2 is ratio. We know these steps now. Yeah, the ratio is an invisible. I'm going to do this in green. A 1 there and a 2 here. So the ratio is, going to do it in red again, is a 1 to 2 ratio. Put it underneath the iron. Why not? To go from there to there, we times by 2. So I'm going to take that number on my calculator. Now I've written down 0.788, but I've kept on my calculator 0.7875. I've kept it there. Times by 2, which gives me 1.575. So that gets rounded up to 8, but I keep that number on my calculator. Ratio used. Step number 3, get out of moles. Yep, so let's just reorganize my equation. Number of moles is grams over rams. Bring the rams over. Number of moles times by rams gives me grams. How much does iron weigh? Iron weighs 56. So I'm going to multiply that number on my calculator by 56, and I get a mass of, and I'll do this in green, maybe? Sure. 88.2 grams, and there's my final answer. So guys, if you've got 88.2 grams, you get 1 mark. Now we go on to the next question, which is 78.5 grams was actually formed. What is his percentage yield? Percentage yield is actual over theory times 100. So his actual was 78.5 over my calculated of 88.2 times by 100, and I get 78.5 divided by 88.2. My calculator is missing numbers. My calculator is a really ancient calculator, and it's all sticky. 89% exactly. Tick it if you got it. Winner. 2 marks for question 1. Okay. If you didn't get those answers, if you didn't manage to get those, guys, what I'm now going to ask you to do is pause the video and have a go at question number 2 again. I'm looking to reinforce the correction. Yeah, if you've got that wrong, stop the video, pause it, have a go at question 2, following my method, and giving a different answer. Yeah, so do that. Have a go at doing that. If you're struggling with this, run that process. Pause the video, no questions on the chat, it's fine, and you can crack on with that, and then you can unpause it and see the answer. Okay, so step number 1, calculate the mass of chlorine that can be formed from 50 grams of sodium chloride. Right, okay. So step number 1, do you know what? I still want my equation. It's a long equation. I'm just going to step 1, get to moles. Yeah? Number of moles is grams over rams. We know this. So my number of moles is 50 grams over sodium chloride. What does sodium chloride weigh? Well, sodium is 23 times by 1 plus chlorine 35.5 times 1 as well. Total is 58.5. Lob that in there. So step number 1 is 50 divided by 58.5. And I get the number of moles of 0.854 moles, if you like, doesn't make any difference. Step number 2 is the ratio. So the ratio here, let's highlight it. Here to here, it's a 2 to 1. The ratio there is a 2 to 1 going in that direction. So I'm going to divide by 2. Okay, so 0.854 divided by 2 gets me, it's still on my calculator, the real number. Divide by 2, and I get 0.427350427. I'm just going to keep it at that. but keep the number on my calculator. Step number 3, get out of moles. Reorganize this guy. Number of moles times by rams gives me grams. So 0.427 multiplied by chlorine. Now, chlorine is in a pair. Yeah, so 35.5 times 2, which is 71. Yeah, so I'm going to multiply that by 71, and I get times by 71, and I make 30.3 grams. Ticket if you've got it, folks, 1 mark. He actually makes 25 grams. Right, percentage yield, actual over theoretical over calculated times 100. Times 100, and I get 82.4%. Ticket if you got it. Yeah, 4 marks so far. We're doing well. If you got it wrong, pause the video now and have a go at the next question following my routine. Remember, guys, this is all about routines in chemistry. We want to get you into nice, solid routines so you're understanding the steps you're doing and can run them in your exam on Thursday. Calculate the mass of chromium that can be formed from, they've given us kilograms. That's clever. 1.25 kg. There's a conversion step. I like it. Step number 1. Step 1 is get to moles. Number of moles is grams over rams. Therefore, I need to convert it to grams. 1,250. I've timesed it by 1,000 to put me into grams. Yeah. Over, what does chromium 3 oxide weigh? By the way, Roman numerals missing. That's a mistake. They would have lost that in their test. Yeah, that's chromium 3 oxide. Let's run it. Chromium, I have no idea. 52? Is chromium 52? I haven't got a clue. No! Wow. Got that right. Amazing. Chromium is 52 times by 2 plus oxygen 16 times 3. Add it all up. 52 plus 52 plus 16 times 3. I'm doing it because my calculator likes me to do it in certain ways. 152. Okay, so 152 over there. Grams over rams. 1250 divided by answer gives me 8.22 moles. I like it. Step number 2 is the ratio. Got to roll your R when you say it, folks. So the ratio here is, I'll do it in green, is a 1 to 2. And we're going in this direction. So the ratio is a 1 to 2, moving in that way. So divide by 2. 8.22 over 2 gives me, I've kept that number on my calculator. I've not used the rounded number. Yeah, 4.11. Still kept it on my calculator. Yeah, still got it. It's moles. Step number 3, get out of moles. Yeah, I'm going to switch back to red now at this point. Yeah, step number 3, get out of moles. Yeah, number of moles times by rams gives me grams. Right, what does chromium weigh? Chromium weighs 52. Discovered that before. 4.11 times by 52. I've got that number on my calculator, though. Yeah, so I get 214 grams rounded up. Isn't it multiplied by 2? Oh! Zihan. Fatima, well done. Thank you. It was a test. Yeah, I didn't make a mistake at all. Thank you. I'm an idiot. I don't know what. That's not a funny mistake. Very easily done. It's a times by 2. By the way, just to notice, it would have thrown me way off my maths. So it probably would have come out in the wash. I would have been like, oh, that's very low. So you're absolutely right. It's actually a times by 2 step. Thank you for fixing it for me. 8.22. This is why I've lost the number on my calculator now, folks. So what I'm going to do is I'm going to go back to this step here. 1250 divided by 152 gets me 8.2236842211. Right, times that by 2. Right, now I get my number, 16.4 4 moles, but kept it on my calculator. Multiply that by 52 times by 52. And I get, that's better. Yeah, 855 grams. Now, the reason why this would have come out in the wash is because this was my theoretical, and this is what they actually made. Oh, I wish I'd just left it for 10 more seconds, Fatima, and not looked at the chat. Because what that would have meant was that my theoretical would have been less than my output, and it would have flagged up that I'd made a mistake. Yeah, it tends to come out in the wash, but they don't always. Some mistakes actually do get carried through sometimes, but it does make more sense. So this is my theory. This is my calculated. This is my actual. So percentage yield equals actual over calculated times 100. Actual was 756 over 855 times 100. 756 divided by 855 times 100, and I get 88.4% ticket if you got it. So 2 marks. I would have lost one there for sure, guys. As I said, probably would have come out in the wash, but thank you for catching it. I really appreciate that. I now know that Fatima and Zihan are the only 2 people paying attention. Right. Question number 4. I put instructions on the chat, didn't I? Okay. Yeah, you're not going to like me very much on this one, are you? See, I apologize. I think I put the instructions on the classroom. We'll see. So, calculate the mass of ammonia that can be formed from 12 grams of hydrogen, and we're wanting that guy. Okay. Step 1, get to moles. Number of moles. Step 1, moles. Number of moles is grams over grams. So we've got 12 grams over 2. Lots of people make the mistake of doing it over 1. It's not. It's H2 in the equation. Yeah, so that's 6 moles. Right. Step number 2, ratio, which is a 3:2 ratio. So I need to divide by 3 times by 2. Let's see if I can actually do what I actually show now. Yeah. So 6 divided by 3 gives me 2. Times by 2 gives me 4. I'm going to get 4 moles of ammonia. Next, step number 3, get out of moles. Number of moles times by rams gives me grams. So we've got 4 moles multiplied by 17, the MR of, so 4 times 17. I could have done that entirely in my head, but I wouldn't have done it anyway. 68 grams is what I'm expecting. And then in reality, we got 20.3. Big loss. Percentage yield equals actual over calc times 100. So I got 20.3 in reality over 68 times 100. 20.3 over 68 gives times 100 gives me, oh, that's great. Isn't that clever? Rounds up. No, it doesn't. 29.9%. Nice. Nice. Take it if you got them. Tick. Next, give 3 potential reasons why the percentage yield was less than 100%. Right, I put these on the chat. I missed it in the lesson. You guys have to be able to give reasons for these, and there are many reasons for us never getting 100%. But there are often top answers. Yeah, so number 1, noise. Nice, Zihan. It's one of my favorite shows. Do you know the TV show? Incomplete reaction. Top answer. Incomplete reaction. Side reactions. What that means is alternative products I didn't expect. Yes, well done, Kate. It is indeed Brooklyn. I love Brooklyn. Do you know what? I've been so disappointed with the latest season. It's just not the same. I feel like the actors have given up on it. Side reactions, alternative products, the same thing. Yeah. Impurities. Oh. Impurities. Impurities in reactants. Those are my answers. 1 mark for each one, folks. You can also say if you've put reversible, I'll also do that. I'll also give that one if you've put it. Reversible. But those are the top 4. Next, okay, titanium is made. Any of those 3, by the way, I'll get you 3. Titanium is made by the reaction of titanium chloride with sodium. Calculate the mass, 10 kilograms. Again, another clever conversion step. So they've given me 10 kgs of this guy, and they want the mass of titanium. But at least a 1-to-1, that's nice, isn't it? Step number 1, get to moles. Number of moles is grams over grams. So I need to convert. So 10 kg becomes 10,000 grams. Divided by what does tickle weigh? Titanium, 41. Way out. 48. Titanium, way out. So that's going to be 48. Titanium is 48 times by 1 plus chlorine at 35.5 times 4. So 48 plus brackets 35.5 times 4. 190. I had a feeling it was 190. I nearly said it, but then I thought I embarrassed myself. Divided by 190. So I get moles of 52.6 moles. Ratio. The ratio is 1-to-1. I still get a mark for writing that down in the exam, by the way, just so you know. That means, though, because it's a 1-to-1, I've got the same number of moles. So step number 3, get out. Number of moles times by rams gives me grams. So I've got 52.6 multiplied by titanium at 48, which was over there. I've got that number on my calculator. I'm not using 52.6. I'm using 52.63157.895 times by 48. And I get 2,526 grams. Yeah, or 2.53 kgs divided by 1,000 if you want it in kilograms. Not that it makes any difference. Right, they actually, so it was better to leave it in grams in this case because they're giving us grams in the next step. So percentage yield is actual over calc times 100. So the actual was 1950 over 2,526 times 100 times 100. 1950 over 2,526 times 100, and I get 77.2%. And I'm done. My homework is finished. Amazing. So what's it out of? Total homework is out of 2, 2, 2, 2, 3, 2. What's that all add up to? 13. Whoop, whoop. Total is out of 13. Let's fill in the sheet, folks. Let's fill in the sheet. Let's have a look. Let's have a look, shall we? Oh no, gone Yorkshire. Oh no. Hello. Gotta track down my sheet. Hello. Right. Don't know. Starred. I starred this one. Made it. I'll double. There it is. There it is, lads. Lids. Double award homework data. Let's see how you guys got on. A couple of people missing their data from their empirical formula. Homework. Oh, look at that. Oleg, 11. Well done, Oleg. Great job. Seeing if I can add in the name of it. There we go. Percentage yield. I can shrink that. I need to wrap the text, don't I? Wrap. Oh no, that didn't work. There we go. And it's out of 13. Outstanding, guys. Look at this. Great results. That's amazing. Guys, that's really, really good. I'm so proud of you. It's been an absolute pleasure to teach you guys. Really going to miss you when you go. Really will miss you. Oh, there you go. I'm missing Ethan's empirical. It's interesting that the Ethan, Chimon, Boyang, and Ryan. Guys, can you just quickly say hi on the chat just so I can make sure that you guys are still there? It's just, oh, there you go. Well done, Chimon, for getting there. That's great. Thank you, dude. Appreciate it. Ethan, you're still there on the chat? There's Chimon, you see, he's responded. There's Ryan. Hold on, still loading. No problem. Oleg's in, thanks. Oleg, what an outstanding result. 11 out of 11. Oh, sorry, you got 11 out of 13. That's still a really good result. Really pleased. Oh, hang on. Is that? Yeah, I'm really happy with that. Who got 13 out of 13? Fatima, you've smashed it. Well done. Who's that one? Kate, well done. Superb. Great job. Really proud of you. You guys, and still, look at this. Chimon with 10. That's a great score. Did you lose it on the bit that I hadn't taught you? That's an interesting question. Was it this bit that threw you off? I put it on the classroom chat. Was it those three that threw you off? I feel like it was a bit unfair for me to have... the answers were on the classroom. I actually posted them directly on there. I don't actually mind that having happened because it meant that you had to have read the classroom notes and probably gone back several times to reread them. That's totally okay. You can add that to your book notes. Yeah, that bit. Yeah, Zihan, I actually put the answers on the classroom. They were actually there in the instructions bit. I did wonder whether or not people would miss it. I did wonder. Guys, I'm really, really happy with those scores. They're fantastic. If you have done all these homeworks and got these scores, guys, you will smash your test on Thursday. Yeah, right. Let's go back to our lesson. We're nearly done today, folks. We're nearly done. So, just a quick calculations review. That's all I want to do. Just a quick calc review. Okay. So the great thing is, of course, for me, and like you should also have your book notes. Yeah, at the very start, I gave you guys a list of the calculations you need to be able to do. And here they are. 7 calculations in double award. What about the empirical formulae homework? Oh, did I do another one? I did, didn't I? I did do another empirical formula homework. I said that really, that's a really good point. I did set you guys another one, didn't I? How long is it? I'd kind of like to do the review before your exam. What I should probably do is, in that case, did you guys all manage to get it done? Oh, you guys are the best. Year 10. Which empirical did I give you? I can't actually remember. Empirical formula 3, I believe. Was it this one? 5 questions. Yeah, it was that one, wasn't it? Okay. Would you like me to review it? I can review it if you like. It was 2. Oh yeah, empirical formula 2, but I've named it 3 because that's what I mean. But I haven't really labeled my homeworks particularly well. I can go through these if you like. I can. Please review. I like that. Kate says, please review, and Oleg says, it's okay. Yeah, I can review. It'll take the rest of the lesson and I won't get to, but I can do it. Okay. What that means, guys, if I'm just going to quickly review the empirical formula, which I think it is worthwhile doing, it does mean that you'll have to do your own review in terms of your own revision. And it's just going over all these calculation types. I'll post on the classroom today a booklet of questions that you guys can do. They're just practice exam questions. I'll post the mark scheme with it so that I don't have to review it. You can mark it yourself and then ask me any questions over the next 2 days. But I will indeed review. Okay, so I'll get rid of that calcs review and I'll do empirical number 2. Insert, let's see if I can pick that up there. Insert, print out. There we go. Oh, it's being used by another file. Really? Oh, yes. How fascinating. Let's try that again. Oh, there might be something wrong with it. That's interesting. That's strange, isn't it? How bizarre. I think it's because I had it open. Because it opens just fine here. What's the issue? I don't know why it's saying that. Go figure. Don't think it'll let me write on this either. I can do screenshots. I can indeed do this. Okay, I'll do it this way. It means it won't be on my channel, which doesn't matter. Right. Butane has the molecular formula. Explain what the molecular formula tells us about butane. Butane contains 4 carbon atoms. 4 carbon atoms and 10 hydrogen atoms. That's all it tells us. That's it. Yeah, the actual number. Yeah, brackets. Actual number of atoms. Actual number of atoms of each element in compound. It's the definition for molecular. What is the empirical formula for butane? C2H5. Explain what the empirical tells us. The simplest whole number ratio. The simplest whole number ratio of atoms of each element in the compound. There we go. Next, right now I need to take a new screenshot. I don't know why it's being so bizarre. Probably do these 3 together. Oh, there we go. Let's go for those 3. Full screen snip. Okay. Percent to mass. Mass to moles over 27 over 35.5. 20.3 divided by 27. Oh, 20.2. So easily done. 20.2 divided by 27 gives me 0.748. 79.8 divided by 35.5 gives me 2.25. I can actually use the rounded numbers in this case because we need the whole number ratio, which means it's going to round it anyway. Yeah, it's going to give me a 1, and then 2.25 divided by 0.748, and I get exactly 3. Yeah, divide them all by the smallest. There's my numbers. So the final thing is ALCL3. Done. No half or fraction, so I don't have to multiply. Next one, they've already done the hard work. Over 12, over 1, over 16. 0.6 over 12, 7.2. Oh, that doesn't make any sense, does it? 0.6 divided by, I hit times on my calculator. 0.05. 0.10, 0.8 divided by 16, 0.05. Divide them all by the smallest. Final answer. Nice and easy. Percent to mass. Mass to moles. Grams over rams. 72.4 divided by 56 for iron. 27.6 divided by 16. Divide them all by the smallest. Here's the first fraction. 1.725 divided by 1.29. 1.33. It's a fraction. It's a third. Times it by times everybody by 3. Yeah. FE3O. That's weird. (1.33 times 3). 4. There we go. I'm just going to check those numbers. It's a very unusual formula, that. 72.4 divided by 56. 1.29. Yeah, it is correct. 27.6 divided by 16. 1.2. Yeah, it's all correct. It's good. That's correct. So tick them if you've got them. Let's go to the next one. Last one on this part of the sheet. I'll take that so I can do those two together. Full screen snip. Right. Grams over rams, already done for me. Boron. Hydrogen, helium, lithium, beryllium, boron. 5? (11). It's element number 5, but atomic mass 11. That's just going to be the same number. 0.5156 divided by 11 gives me 0.0468. Divide them all, 469 technically doesn't matter. It's not going to matter. It's going to come out in the wash anyway. 468 divided by 0.0468. That's 1, so B1. And then H, 0.0844 divided by 0.0468. 1.8. Oh, that's awkward. I made a mistake. I made a mistake somewhere. It's really unusual. It is 4/5, but that seems a bit crazy. 0.5156 divided by 11. 0.0469. Let's put 9. Let's round that up. I don't know if that's going to actually make a difference. It shouldn't do. Yeah. And then that one is correct. 0.0844 divided by 0.0469. 1.8. That's really strange. It suggests times by 5. Really horrible. It's 4/5. B5H. Ugh. It's horrible. 9. I need to check the answer on that one, guys. It's really weird. Have I done something wrong there? It's very unusual. I've never seen it times by 5 before. It's because 8 is 4/5, by the way, if you're wondering. So you multiply by the denominator when you convert to a fraction. It's really strange. Ugh, it's horrible. This looks harder. 0.86 grams of iron reacts with chlorine to form, okay, so iron reacting with chlorine to form iron chloride. And the question is, we don't know what the numbers are of everything, but what we do know is that 0.86 grams of iron, right, has formed 2.496 grams of that guy. So we can work out the mass of chlorine that's been picked up. That's what we can do. Yeah, so we can do 2.496 minus 0.86. 2.496 minus 0.86 gives me 1.636 grams and grams. Right, now that we've got those grams, now we can do moles. Yeah, grams over rams. Over 56. Over, yeah, you've got to divide it by atoms now, remember. This is not a reacting mass now, this is empirical. Yeah, you've got to divide it by 35.5 to count the atoms, not the molecules. That's the trap there. And I've got that on my calculator, so I'll do that. That's going to give me 0.046 of atoms of chlorine. Yeah, 0.86 divided by 56. It's a clever trick, that. 153. It's actually 154 if you round up. Divide them all by, oh, hang on a minute. I've missed a 0. So easily done. Yeah, there we go. 0.0154, 0.0154. That's 1. 0.0461 divided by 0.0154, and I'm going to get exactly 3. There we go. FeCl3. So that one worked out nicely. Guys, did you guys get that crazy answer? It's vile. Can't round up. Can't do it. It's too far away. Just to let you know, by the way, in reality, people are going, you didn't get 3. I actually got 2.99, which that you round up. But you can't round up if you're any decent distance away. Yeah, you just can't. Sorry about that. Just kind of the point of the worksheet, I guess. I mean, we're meant to be reinforcing this. This is kind of the point. Last page, and then I'm done for today's lesson. Full screen snip. Amazing. Right. An oxide of copper was reduced to copper metal by reacting it with hydrogen, given a word equation. Use the data to calculate the empirical formula of this copper oxide. Okay. So it says the container plus copper oxide. So let's work out the copper oxide. Yeah. So CuO. Now, we don't know what the numbers are here. Yeah. X and Y. What we're trying to work out here, just to zoom in. Yeah. CuX. We don't know what the numbers are for the copper oxide. That's what it's trying to work out for us. Yeah. And it's gone to form copper. Yeah. So what we can do is we can work out the oxygen that's being lost. We're removing, yeah, I know it says in this case hydrogen, yeah, and water, which is going to be a bit tricky, this one. Plus hydrogen goes to Cu and water. Okay, let's see how we get on. So the first thing is we need to minus the container. Yeah, so 52 and 25. So the first thing is I need to get rid of the container from that to work out the copper oxide. 26.97 minus the container. Yeah, I think everyone's okay with that. 26.97 minus 25.61. It's going to give me 1.36 grams of copper oxide. Right. Now, container with the copper after the reaction. So we can now work out the mass of copper. And that's going to be 26.82. Sorry about that. I ought to shrink my pen a bit. Make it a bit skinnier. Yeah, 26.82 minus the container, 25.61. So 26.82 minus 25.61. And I get 1.21 grams of copper. Right, that actually gives us everything we need, doesn't it? Because we can now go our usual process of copper and oxygen. And I had 1.21 grams of copper, and I can work out the difference to give me oxygen. 1.36 minus 1.21 gives me 0.15 grams of oxygen. Right, now I can do my empirical. Grams over rams, over 63.5, over 16 for oxygen. 1.21 divided by 63.5 for copper gives me 0.0191, technically rounded up. 0.15 divided by 16 gives me 9.38 times 10 to the minus 3. I don't like that. What I'm going to do is I'm going to just go Shift-Eng on my calculator. So it changes it out of standard form for me. 0.009375. Right, that one is smaller than that one, so divide them all by the smallest. 93. I love that calculator button, you know. It's one of my favorite things I ever discovered. 0.0191 divided by answer gives me 2 dead. 2.04 technically, but that's 2. So the empirical is Cu2. Oh, it's copper 1 oxide. Very rare. Very rare that. There we go. Right. Next, I'm nearly done. 10 minutes to spare. So it's given us the empirical. It's given us the formula mass. We know that this is the simplest. Yeah, empirical means the simplest ratio. Well, this is the actual. Well, when we were doing the funny games of, if I give you C8H16, what's the empirical? We know that we divide this one by 8 to give me CH2. We're doing the divide by 8, yeah? But this is the reverse of this. We want to find out the divide process. So what we want to do is we're going to weigh the empirical, and that's carbon is 12 times 1, yeah, plus hydrogen at 1 times 2. So that's going to be 14. 14 empirical, right, 44 divided by 14, 42 even, sorry, divided by 14, gives me 3. So I'm going to multiply, so this equals 3. It's a times 3 process. That becomes C3H6, and I'm done. Tick it if you got it. Next, IF3, formula mass. Okay. So what does IF3 weigh? Oh, iodine's massive. 126, I believe. Eek, I don't know. Is it 126? Iodine. Fluorine's 19. That one's easy. Iodine, 127. So close. So close. So close. 100 and iodine is 127 times by 1 plus fluorine at 19 times 3. So 127 plus 19 times 3 gives me 184. There's my real. Oh, the real is the same. So the empirical formula is IF3. That one's nice. Thank you. Oh, that's interesting. NH2. So nitrogen, which is 14 times 1, plus hydrogen, 1 times 2, giving me 16. Oh, that's easy. To get to there, times by 2. So that becomes N2H4, and I'm done. Right. Molecular formula. Oh, that's clever. So they're just getting us to simplify. Oh, this is our usual game. Nice and easy. So we cannot simplify that. So the formula mass is going to be 12 times 3 plus 8. So 44 for propane, and its empirical formula is the same. It cannot be simplified, which is quite nice. Because you can't divide, it's the 3 that's stopping it. It can't be divided by any number to make a whole number, so we can't do it. MR for glucose, 180. Empirical, C2. No, tell a lie. CH2O, and I'm done. That's it. Blimey. I hope you found that useful, guys. There's 5 marks for the ending there. Let's work out the total marks. Find empirical, 1 mark for that guy. 1 mark for that guy. 1 mark for that. Did everyone get that crazy guy? On the chat, please. Who got that? It's weird, man. B5H9. Ugh. That's what I got. Weird. Really weird. And then 1 for each of them. Total marks, of course, is going to be, I don't know. What's the total marks out of? Somebody added up for me because I'm in sections. I got it. Good. Katrina, well done. I skipped. Fair enough. What's the total marks out for that worksheet? There we go. So let's just have a look. So we've got what it tells us, the actual number of atoms. What is the empirical? What is the empirical formula? What's the empirical tell us? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, technically. So that is 16. I rounded the 1.8 up. Yeah, Fatima, I can understand why you did. You can't do that, I'm afraid. It's too far away, just so you know. You never really round on empirical, except when it's like 2.9 or 2.98. Yeah, the 9/8. So it's got to be super close for you to round up or round down. But that's unfortunately 4/5. Crazy one. Don't worry about it. What did I just say it was out of? I don't remember. What did I say it was out of, guys? I can't remember. 16? I've lost it. I've lost my mind. 16. Yeah, you can add them up and lob it into that sheet. Right, guys. So you guys are well prepared. You guys are going to smash your test on Thursday. I know you will. I'm going to leave you guys be at this point. If you have any questions for me, guys, if you've got any questions about any calculations, and as I said, I will set a homework for you guys to do, which will just be generic calculations, all the calculations that are going to be on your test, and I will include the mark scheme. All right, guys. I will see you on Thursday. See you later, guys.